Picture this. You've got a massive multi-ton machine whipping a heavy steel arm around at something like 5 meters per second. Now, imagine accidentally stepping right into its path. It's a terrifying thought, right? So why do robot accidents actually happen on the factory floor? And more importantly, how do modern safety sensors manage to step in at the absolute last millisecond to save lives? Welcome, everyone. In this explainer, we're going to pull back the curtain on the incredibly high-stakes reality of working right alongside industrial robots.
We're going to completely break down the complex and honestly fascinating world of industrial robot safety. So whether you're a beginner just trying to get a handle on the basics, a tech on the floor, or a veteran automation engineer, this explainer is going to take you from the core foundational concepts all the way up to cutting-edge professional safety standards.
Okay, here's our game plan for today. First, the need for safety, followed by the essential hardware components, then how it all works together with industry standards. After that, we'll hit the real-world hazards and precautions, and finally, wrap up with the future of automation with DEVI automation. Let's just jump right in.
Part 1. The need for robot safety.
You know, a lot of folks kind of lump general industrial safety in with robot safety, but they are totally different animals. General safety, that's about making sure you're wearing your hard hat, taping down tripping hazards, or putting up a wet floor sign. But robot safety focuses specifically on the dynamic, high-speed, and sometimes unpredictable motions of automated machines. I mean, if a worker wanders into an active welding cell, a yellow caution sign isn't going to save them. We need highly intelligent systems that can instantly detect a human presence and kill that kinetic energy on the spot.
And we're dealing with a massive variety of machines here. You've got those heavy-duty articulated robots welding car chassis, super-fast SCARA robots doing horizontal assembly, and those crazy spider-like Delta robots snatching up items and food packaging. Plus, you've got collaborative robots, or Cobots, built to work literally shoulder-to-shoulder with humans, and AGVs zooming around warehouse floors. Every single one of these platforms demands a highly specific safety architecture to make sure they can do their jobs without putting the human workforce at risk.
Moving right along to Section 2, Essential Safety Components.
So, what's our first line of defense? Usually, it's physical hardware. Think about a heavy safety fence built around a robotic arm. But it's not just some dumb chain-link fence, right? It's rigged with safety door switches and interlock systems, so if a supervisor pops that door open while the robot is mid-cycle, the interlock instantly cuts the power, no questions asked. We also use things like safety mats on the floor. If you step on one, the machine immediately knows you're there. These physical barriers and limit switches are the rugged, absolute front line of worker protection.
But hey, physical fences aren't always going to cut it, especially not in today's open-concept smart factories. And that brings us to the optical sensors and controls. We're talking light curtains, which are basically invisible walls of lasers that trip an alarm if even a hand breaks the beam. We've got area scanners and vision cameras actively mapping out the environment. And the absolute brain behind the whole operation? That's the safety PLC. It acts as the central command, taking in all these sensor inputs and deciding in literally fractions of a second if the robot controller and servo drives need to slam on the brakes.
All right, Section 3, Working Principles and Standards. Now this is where it gets really cool, how this safety loop actually functions in real time. Imagine an automotive robot doing a high-speed weld. An operator accidentally takes a step past the safety line. Step 1, the operator breaks the light curtain. Step 2, the safety sensor catches it and fires off a signal. Step 3, the safety PLC gets that signal, overrides all normal factory logic and practically screams at the robot controller. Steps 4 and 5, the controller tells the servo drives to drop power, achieving a dead-stop emergency halt. This entire chain reaction happens in milliseconds. It literally has to.
And look, because the stakes are so incredibly high, absolutely none of this is left to guesswork. The whole industry is locked down by strict, non-negotiable global standards. You've got ISO 1021-18 covering industrial robots, while ISO 15066 specifically dictates how those cobots we mentioned can safely bump into a human without causing harm. There's also IEC 61508 for electronic functional safety, plus CE standards for Europe. Honestly, if a factory isn't complying with these, they aren't just risking a hefty fine, they're risking human lives and completely catastrophic legal liabilities.
Which brings us to Section 4, Hazards and Precautions.
Let's be real for a second about what we're actually trying to prevent here. The hazards are brutal: high-speed collisions, getting crushed against a wall, horrific pinch points, or lethal electrical shocks. So, we fight these severe risks with equally hardcore precautions. The holy grail here is LOTO, lockout, tagout.
If a maintenance tech goes into a cell, they physically padlock the power switch. Nobody can accidentally boot the robot up while they're inside. We pair that with proper PPE, ultra-safe low-speed programming modes, and strictly authorized access to keep untrained folks safely out of the zone.
Now, there is this huge myth floating around the industry that safety protocols just bog down production. It is totally false. Yes, keeping workers safe is the ultimate goal, no question, but the business outcomes are undeniable. A perfectly safe robot cell means you aren't dealing with catastrophic accidents, and that translates to higher productivity, massively reduced downtime, and way better machine reliability. We see it in real case studies all the time, from welding to packaging. Doing safety right actually lowers your long-term maintenance costs and boosts your bottom line. It's a win-win.
Finally, Section 5, the future with DEVI automation. We are stepping right into the era of Industry 5.0, where heavy metal cages are quickly becoming a thing of the past. The future of robot safety is entirely proactive. We're talking AI-based safety and vision-based human detection that can literally predict where an operator is walking and dynamically slow the robot down before they even get close. Throw in predictive safety monitoring powered by the industrial Internet of Things, and it's a whole new ballgame. The smart factory of tomorrow doesn't just slam on the brakes during an accident, its AI anticipates the hazard and just navigates around it seamlessly.
Of course, pulling off that kind of smart, connected architecture takes serious know-how. And that's exactly where DEVI Automation Solutions steps in. They are totally at the forefront of implementing this tech. Whether you're looking at complex PLC programming, SCADA systems for deep data monitoring, injecting AI into your lines, or building out a fully realized IIoT smart factory, DEVI Automation Solutions brings the heavy-hitting engineering needed to keep your facility humming and, most importantly, completely safe.
So, as we wrap up this explainer, I want you to keep this core philosophy in mind. Safety is always the first priority in industrial automation. It's the absolute foundation of everything we build. If you're looking to dive deeper and bring this exact level of next-gen security to your own operations, definitely reach out to dvautomationsolutions@gmail.com. And I'll leave you with this one final thought to chew on. As our machines become more intelligent and autonomous, is our ultimate safety net going to be a physical emergency stop button or an AI that knows we're in danger before we even take a step? Thanks so much for joining me. Prioritize safety out there, and I'll catch you in the next explainer.